Dear students, in the previous lecture, we have studied about the basic difference between accuracy and precision, then the discussion of errors and different types of error. We are remaining with one last type, that is the random error. We will discuss today about the random error, how this error is generated, how it can be eliminated, and numerical based on the random error.
Random error. The error which occur irregularly at an random in magnitude and direction are called random errors. Such errors occur by chance and arise due to slight variation in the attentiveness of the observer while taking the reading or because of slight variation in the experimental conditions. For example, if a person repeats the observation a number of times, he may get different readings every time. Random errors have almost equal chances for both positive and negative errors. Hence, the arithmetic mean of a large number of observations can be taken as the true value of the measured quantity. Now you can say even if instruments are perfect, training is perfect, personal errors are removed perfectly, even then the measurements can suffer from error and their cause are not identified. This is known as random error. If I ask you to measure the length of your classroom, you would not get the same results. And I can see that you are having values on both sides of true value. Suppose actual length of room is 5 meter and you have measured 4.9 meter, 5 meter and 5.1 meter. The actual value is 5 meter. Your observations are on the both side of the true value. So their removal becomes difficult. Now we will discuss how to remove the random error. Suppose A1, A2, A3 up to An be the n measured values of a physical quantity, then its true value A bar is given by the arithmetic mean, that is A1 plus A2 plus A3 plus A4 up to An divided by n. This gives you the true value, and true value is represented by A bar, and in the form of summation you can write it as you are observing here. The summation means the sum of the values, and that is summation of ai means the I is starting from 1 and ending at n. When you are having n I is equal to 1, then you have 1 by 1 and a1. If you are having I is equal to 2, you will have 1 by 2 into a1 plus a2. If you have I is equal to 3, you will have 1 by 3 a1 plus a2 plus a3. So this is the summation is the compact form of this expression, and you have a bar is equal to a1 plus a2 plus a3 plus an divided by n. By doing so, we can remove the random error. Next one is the absolute error. What do you mean by absolute error? The magnitude of the difference between the true value of the quantity measured and the individual measured value is known as absolute error. Students, here you have different observations, suppose a1, a2, a3 and so on, and a bar is the true value. It means your different observations are lying either on the positive side or on the negative side of the true value. It means if your value is 5 and you have observed 4.9 and 5.1, it means 4.9 and 5.1 they are lying close to the true value, that is 5. So we can calculate the absolute error in each quantity. How we can calculate? Suppose we are going to calculate the absolute error in the first quantity, that is A1. What we will do? We will subtract the observed value of A1 which you have observed from the true value. I've told you the true value is 5, and suppose you have observed 4.9, so you will subtract 4.9 from 5 as shown on the screen. That delta A1 is the absolute error in A1, absolute error in first quantity. How you will determine it? A bar is the true value. Subtract this A1 from the true value, you will have the absolute error. Similarly, you will repeat with all the terms, and this error is known as absolute error. Then the mean absolute error. Mean absolute error is the mean of all the differences which you have calculated. What you will obtain, students, in some cases you will have that difference positive, and in some cases you will have the difference negative. This bar in the figure, that delta A bar is equal to mod of A1 plus mod of A2 plus mod of A3 up to AN divide by n. What is the meaning of this mode? This mode is representing you the positive value. Always you have to take the positive value, whether the difference is difference of what? A bar and A1, or A bar A2, A bar A3. Whether this difference is positive or negative, in the mean absolute error you have to take the positive value only. Why this is so? Suppose one time you have made the positive error, next time you have made the negative error, and if you are not taking them positive, then total net error is 0. But it is not possible. You are committing the mistake two times, and net error shall not be 0. There must be some error. So always the errors are added. We never subtract the errors. Next is the relative error. Relative error is the ratio of mean absolute error to the true value of the measured quantity. This is denoted by bar of delta A and divide by bar of A. What is delta bar A? This is the mean absolute error, and what is in the denominator? That is the mean error, that is the actual value. The next one is the percentage error. The percentage error, when the relative error is expressed in the form of percent, then it is known as percentage error. Dear students, all these errors we will study with the help of an example. For example, the length of a road is measured as 2.48 meter, 2.46 meter, 2.49 meter, 2.50 meter, and 2.48 meter. Find the average length, absolute error, and percentage error. First of all, what you have to do, you have to calculate the true value. How you will calculate the true value? By taking the mean of these all values. So you will have the mean, and that comes out to be 2.48 meter. How you will calculate the mean? Add all the values and divide by the total number. There are 5 observations, so you will divide by 5, and the mean comes out to be 2.48 meter. Now the term calculation of absolute error. What was there? The absolute error was subtract the observed value from the average value or the true value. True value is 2.48. So first reading is also 2.48. So subtract 2.48 from 2.48. Then second value is 2.46, and true value is calculated true value is 2.48. So 2.48 minus 2.46. From these observations, you are able to see that some calculations are positive and some are negative. But when you will calculate the mean absolute error, you will add all the values whether their sign is positive or negative. And finally, the error comes out to be 0.01 meter. Now the correct length will be the true value. True value is 2.48 meter, and the mean absolute error, that is 0.01 meter. The plus minus sign indicate that the range of this value, the value may lie 0.01 below the 2.48 value or 0.01 above the 2.48 values. And for calculation of the percentage error, what you will do, the mean absolute error, that is 0.01, divided by the true value, that is relative error, and relative error is multiplied by 100, so you will have the percentage error.